So welcome everybody. Good morning, good afternoon, good evening. Depends on where you're joining us from. Thank you all for joining us from wherever you are. And welcome to this panel. It's a joint panel by EuroIX and Amsterdam Internet Exchange. And it's on the flaws of the internet. So the panel series is called Is the Internet Broken? We had the first one in August, and this is the second panel series. And without any further delay, I am going to hand over to Mark Bruyere, who's the moderator for this panel. Thank you.
Then, hello everyone. Then I've been following the first panel who was organized in August and so, and I was kind of excited and so, and engaged different questions and tried to get something maybe exciting to respond to the first panel itself. Where one of the things would come up when the title is mentioned is internet broken. There is few things that need to be fixed and so, and it's been introduced in that first panel by Henk. He had a blog post and who resumed different things there and so, and out of the panel, he mentioned two different things that was kind of interesting. We need to get some solution. We need to get some solution from bottom to up and experimenting as internet exchange community. Then from there, also in the same day, had another conference with the SIGCOMM and a kind of in light with the beginning of internet. We come from academics, come from operators, come from communities of different people. And so, and that the single day had the possibility to experience that things where through mostly Zoom and other application, be able to feel that that day could create another panel. That's the one today. And when we think of the different experimentation has been done and different things who may succeed or not, and it also come from how academics been working and trying to get solutions with different type of success and so, and different experiments. In the panel, we have different people from different locations. We wanted to get from different regions worldwide. From Australia, we have Narelle Clark, who is in charge of AA. Hi, Narelle. And then Brad, who is president OpenIX and also CDN, and this effort for America, mainly North America, for standardized effort for around internet exchanges. And Kevin from ISOC, who represents Benefits right now in Australia. The effort for ISOC, mostly for Africa, was one of the desires, so to get it a different point of view from there. And Thomas King from DKIX represent EuroIX in some right region, but specifically, yeah, DKIX, different experiments that we can talk. There is going to be two times in the panel. The first period we will be talking about bottom-up experiments, those different regions that may have different experiments as well, feedbacks, success, failure, what could be done, what the different actors doing experiments in those regions, what should be done to do so, and discuss different existing projects already running. And in the second time, the paper was presented at SIGCOMM, the exact day of the first panel, with a public option for the core, have a kind of proposal, and is open discussion. The different panelists have been able to read the paper before. I will be a little bit presenting the end of the second period, what the main point of that proposal in that paper and architecture in the way they propose. But to start, In the first panel that mentioned ink, we had that experiment with running, which is called Two Stick, who is actually focusing on security, stability, and transparency. With opportunity today from kind of industry was opening up down to the data plane with um, the previous SDN concept with programmability of the network equipment down to the data plane, like P4 language. They actually deployed, they have a test bed in Netherlands. Then I want to open the first question to the panel. Like this experiment, does anyone in any regions had in the past such one with obviously different technologies or existing one today similar? And what is your point of view and benefits could be done out of this kind of test bed?
Okay, well, did you
Kevin, yeah.
jump in, is it?
Yeah.
Okay, so I think these sort of future internet initiatives have been discussed for about, I would think, at least 15 years, maybe. I mean, I think probably if you take other, things like IPv6, if you call that a future internet, it's probably 25 years or more. But let's say, completely redesigning the, the architecture of the whole internet or something that might replace the internet. I do think, yeah, there's probably been talking about for about 15 years here, and there's been a number of different initiatives with varying degrees of success. I think, I think these are born through a sort of frustration that the internet isn't perfect and it has a number of problems. I mean, the internet also has a number of good things as well. I mean, considering that the protocols were developed 30 or 40 years ago, I think they have actually worked and scaled remarkably well. Because the internet is much bigger than it was ever probably envisaged to be at the time. But quite clearly there are frustrations, and for example, there are inefficiencies in the way data is transmitted. There's inefficiencies in the routing system. There's security, certainly plenty of security issues. But I would also say that, the internet has also addressed a lot of these problems as well. And the actual, the conventional internet has addressed a lot of these problems. And I feel that in many ways, it's actually more of a problem that the internet hasn't been implementing these solutions rather than the fact that they don't exist. So I think it's very important that these, things like NDN and I guess, I don't know how you pronounce it, Sion or Xion, which offer, some quite interesting concepts. I would see these a little bit more of something that's kind of built on top of the internet rather than replacing the internet. I mean, it'd be nice to sort of start with a clean slate and throw everything away, but I think in practical terms, I think you're going to have to work with a lot of legacy infrastructure and the fact that there's a lot of, experience in building an existing internet, and you just can't sort of throw that away. So yes, I like sort of these concepts like, named data networking, where you can reference things through, names rather than locations. I really do like this. But to me, this is something that's kind of built on top of the existing internet rather than being to replace the internet.
I mean, the beginning of this SDN effort was initiated in Stanford, was a clean slate project they had in mind, just a whiteboard and how it should be today, and so on. We come up with that flexibility proposed by being able to program to the lowest level in some way with proposed architecture, like a match action table and some of the things that we had with OpenFlow. But that specific test bed was the P4 running and so it's kind of just a subdomain of internet. This is not trying to fix the full internet itself. But yes, this is interesting. Thomas?
So yeah, if you look at the internet infrastructure as we manage today, the main principles have been developed, I don't know, 30, 40 years ago, right? So and if you see what the internet is able to deliver until today, it's really tremendous, and we need to say that it does a very great job, right? So we can be very proud how well it works. However, we see that as the internet is growing so quickly and the digital infrastructure is getting more and more important for all of us, we see coming in new requirements. And the question is, how can we develop the internet in such a way that it covers all these new requirements? Like, in the past, we were happy when the internet was working, right? So 20 years ago, we were just happy that it worked. And now we need to talk about how do we make sure it's trustworthy. We can check, that people don't do route or IP prefix hijacks or DDoS attacks and all those kind of security issues we have today. How do we get implemented this new requirement into the base infrastructure? And we also see that, in the past, and it still is to a certain extent, the internet is a network of network, but now we see that large players are getting more and more of the traffic that gets pushed through the internet, and they get more market share, so to say. Even that we see, we have 65,000 networks out there. We see that there's still a lot of communication between the different networks, but the OTTs, how we call them, right? So I don't know, the Facebooks and the like, they get more and more traffic. They see more and more traffic that is pushed into their network, and they get more dominant on this. And the question is, how do we need to develop the internet infrastructure to accommodate these developments and make sure that we are prepared for the future, right? And so, I don't think that we can change the whole, we cannot find one solution that fits all the different requirements. We need to develop it step by step, as we do with IETF today, right? The question is, are we quick enough? Are we fast enough? Are the changes fundamental enough? Probably sometimes we can definitely answer that clear no, right? But still, I see that we develop the internet further and make sure that the requirements can be met. And again, sometimes we need to think about more revolutionary changes, but then the internet is today already a global thing. And how do you change a global infrastructure deployment, which generates billions of revenue, right? And you need to preserve these revenues also while also changing it. That's a tricky task. And so I see, a lot of requirements here, which are not easy to answer and make sure that they are implemented. But yeah, there's a lot of demand for that, and we need to think about how to speed the developments up, right? And
yeah. Kind of different things been responded in the paper that we're going to be talking in some way. Just is opening up the questions, and as a proposal. And Nara or Brad?
Okay, so I'll jump in here then. But I thought that was a very cruel statement of Kevin's, actually, to say that IPv6 is a future internet experiment of the like that we've been trying to do for the last 25 years. We're gradually getting there. I'm feeling a little bit sore about that one, because having sat on the IPNG working group in the was it the mid-90s, where we were trying to think of a next generation internet then, and we came up with IPv6. Yes, we are still trying to get there, but I think one of the reasons why we're still trying to get there is because we've been so busy building this one as it is. We have just spent really the last 30 years, it is 30 years now, that we've been building this internet. And had we sat back then and said, okay, we want to build a completely ubiquitous network to connect absolutely everything you can possibly dream of, and then some more, would we have done it like this? Maybe we would have. I'm not convinced that we wouldn't have done it like this, because there are some fundamentally really good things about the internet and the way that it works now. And one of those fundamental things is that it is an internetwork of networks. We can set our own policies in our own networks and then connect them to others and apply our own policies as we connect and arbitrate between them. We are still, however, in the process of connecting everybody. There's still a lot of people and households and businesses, community places that are not connected today. And throughout the pandemic, this has become very, very obvious to those people that last mile and that last access piece is not yet solved. So I think there's still some more work for us to do before we do get to that truly ubiquitous point. And then after that, we will then break through again and probably find a new version of ubiquity to connect it all. If I get back here to the two-stick question, there are some amazing questions in the two-stick project that they seek to answer, things like path awareness and control. Now, to me, this concept of maybe some sort of banking device that I might have that needs a brand new way of communicating and needs to command a whole suite of encrypted style resources where it you know, does something wonderful and unique to get an end-to-end path. I mean, that would be, and also perhaps if I could decide that path between Australia and Europe via different networks that I then pay a cent to, or you know, a euro to along the way, to make different donations to their business models because I chose to. That would be perhaps an interesting way to do it, but I think we're still a long way off that. In fact, we still, as I said, haven't finished building the first internet, let alone the next few generations of it that we hope to see. And if I'm not going to try and run through all of these high-level questions here, because they really are a great set of questions from the two-stick project that they want to solve. But I have to say, they also kind of remind me of when I first read the 5G specification. And the 5G specification was, I'm trying to think of a polite way to say it. It was fanciful. It had all of these amazing concepts that it was going to do 20 millisecond handover between cells while you were traveling at 200 kilometers an hour, you know, whilst transferring how many gigs of data. I mean, these things they're still quite fanciful ideas. We shouldn't not aim for them, but they're a challenging thing to get to. So perhaps, yeah, I'll end on this concept that I don't think the internet is broken. Would I design it like this if I was starting from a blank slate today to build what we need today? I need to think about that one a little bit longer.
What it seems to be with two-stick is just to get at least as a domain for experiments, like NRENs are doing, because NRENs are part of that project itself.
Yes, if the NRENs can build more creative, interesting ways to test out protocols and do that in a nice, well-contained way so that they don't break everything else, I'm really happy. That'd be great.
I guess I kind of come in as the cynic, I guess. It's something that, again, like what Kevin had said about IPv6. I mean, we're talking about future of the internet here and how we want to do it to help support where we are now with these millions of devices that are connected and users and everything else. But we haven't even solved full IPv6 deployment across the internet. It's just not there yet. So while I love the idea of having this research and building it up, I still think I agree with Nora, we are still ways away. There's still more pressing issues with the current infrastructure that's in place that need to be addressed long before we can move to this next level.
IPv6 is obviously at the narrow point like IPv4 to replace it, but there's different type of protocols and overlay without talking, or different techniques to be using it, which doesn't replace IPv6. It would be incremental kind of vision, but yeah, that change, or maybe the discussion we can get or experimenting today may influence in 10, 15, 20 years.
Yeah, and I think it's kind of along that lines though, is with everything with two-stick, and then also further in discussion when we talk about the public option for the core, I still don't see these replacing what we have today. I see them as a value-add complement to what we have as an overlay, because it makes sense to start planning and having these talks, but how do we standardize it? How do we make this so that anybody who wants to go start a new project has the guidelines available so they have the foot in the door to get there? How do we make it easier for the next generation?
It starts from kind of the chicken and eggs, or just you need to start an experiment at least on the small test bed to demonstrate kind of concept works. Then you can get a standard. You need to reproduce and express exactly what you intend to discuss widely. and then in getting exact interface, like the abstractions you try to define for others to use it.
I want to jump in here because there is something that we've been using for a long time in creating new things and teaching people to build networks, and that is the good old OSI model. Now, of course, in TCP/IP, we don't use all 7 layers. We only really use 4. But we have these as a set of agreed norms that where the layers go. And I have to admit that when MPLS first came along, I had some objections to that because it annoyed me that people were sticking their layer 2 on top of their layer 3s, okay? And it made it difficult for people to troubleshoot. Because I'm quite a practical person and I like to know which layer to look at when stuff breaks. Now, if we start to move across to a whole new set of internet architectures and abstractions and things, we do need to agree early on where the layers are, or at least some sort of architectural framework or model where different slices of the network and different functions of the network sit on top of each other or adjacent to each other or however interconnect to each other so that I can peel them apart when they break. Because if they do get wide deployment, then my customers and members and people that I bank with and care about will use them, and they need to work. And this is the fundamental thing about all of this stuff now. It has to work.
And I would like to add to that, just changing the internet infrastructure to change it isn't really fulfilling a purpose, right? We need to think, what is the goal we are trying to achieve here if we want to change something? And then based on that, come up with a clever idea how to improve or change the internet architecture to make that happen. And so we really need to have a clear understanding what are the goals where we are heading to, what we are trying to achieve before we discuss, big changes or revolutionary changes in the internet. Because again, just changing the internet for the fun of it isn't probably going to work. And we see that with IPv6 to a certain extent, right? IPv4 is still working pretty well. And this is why IPv6 isn't globally deployed, right? We are getting there because we are feeling that, oh, IPv4 might be end of life soon, but what does soon mean, right? Nobody really knows. And this is why, yeah, we spend some resources deploying IPv6, but if you compare that with RPKI, right, for instance, how long is APKI around? For a couple of years now, 2 years or 3 years since it's standardized in IETF, and we already see a take up in the routing table for IPv4 for about 25%, which all the prefixes, 25% of all prefixes have now ROAS, and this is a pretty steady uptake. And the reason is there was a clear goal, a clear benefit associated with this, and then people start changing, right? They start deploying this kind of technology because they see a value, they see a goal, they see something that is in for them. And this is exactly what we need to keep in mind if we talk about changing the infrastructure. It needs to have a clear goal, a clear value, clear benefit. Otherwise, it will be just a nice idea nobody will work on and nobody will pick up.
Kevin, you're...
Yeah, so the concern I have about, I don't want to knock the Future Internet initiatives, because I think some of them, they're doing some very interesting work, and, we shouldn't just sit back and be complacent and say, okay, the internet works fine for now, so let's not look at how we could do things better. But I do think that, we have this problem that there's going to be this inertia issue, that there's a big installed base of existing protocols on the internet. Now, I would argue that if there was a real pressing problem that something had to be fixed, that would fix pretty quickly. So if you go back in time, there was a great routing table sort of impending doom where the routes were, going to exceed the memory and the CPU processing capacity of the routers. So they had to very quickly introduce CIDR. And that was done in an incredibly quick amount of time and deployed in an incredibly quick amount of time on the internet. And Narelle may well remember Jeff Houston and co working on this back in the day, and I think there's been other examples of this where there has been a pressing need for something has to be desperately fixed on the internet. It's got done quite quick. And the fact that future internet ideas have not you know, they've still been milling around for 15 years, and you know, we have some small deployments, but we're not seeing any sort of significant impact at the moment. You know, that probably tells you that maybe there is, you know, it's a solution looking for a problem. Now, I would say I like some of the ideas that they come up with, and I do think some of them will have applicability to the internet. But you know, I want to reinforce my sort of view. I think that probably this is going to be a complementary rather than actually to replace. And it's just whether that's the right thing or not. I don't think that's the issue. It's, you know, that there's just this installed base of equipment, there's this installed base of knowledge. It'd be very, very hard to change that. You know, and the fact that IPv6 has taken 25 years, you know, I've been doing this for 25 years, literally. I was in at the almost the very beginning of this. So I'm really, you know, keen on IPv6, but, you know, there wasn't a pressing need to do it. Perhaps when the addresses finally run out in, you know, a year or 2 years, or 3 years, you may see a sudden change because people will have to. So I think that's kind of often how it gets driven, these types of sort of sea changes in technology. You know, it's a bit like the jet plane, right? You know, you had propeller planes and you very quickly went to jet planes because they were so much better and so much more efficient. And, you know, almost within 5 years, airlines went from propellers, turboprops to, well, not even turboprops, but propellers to jets because it was just so much better. But are these, you know, SDN, is it so much better than what we have now? Good question.
It's a question from the audience. Mark Cart just talk about DDoS was a huge problem, and then even the BCP38 that's not being implemented by many providers. And that's just obviously, yeah, that's something that's even been mentioned in the first panel, was the DDoS is the main problem. And then we try to counter this and so on. Thomas, yeah?
So let me quickly answer on that. So, you know, the problem with these recommendations, how to get rid of DDoS, and we talk about, you know, IP spoofing based DDoS, right? So, and the issue is that if I implement these recommendations, I do it for you. So I need to spend resources to make sure that my network cannot be abused to generate a DDoS for you. And that's the issue in a globally running network, right? So because the value is not clear to me, why should I spend resources? I, as an ISP operator, you know, we do a lot of this kind of stuff, right? But in general, the question is, why should somebody implement this kind of recommendations, which are not easy to implement, to be honest. It can be quite complex if we run a complex network. So why should somebody spend significant resources to make sure that the network of somebody other is protected? And from my point of view, here it makes sense to really come up with research on this new standardization and new technology, which allows to make that a lot easier. And then it will be very easy, right? If it's just switching on, let's say, you know, one knob in a configuration, which just says, you know, make my, you know, make sure that my network is run as based on TCP 53 or whatever it is, then it would be super easy and everybody would do it. But it's more than that. It's super complex implementing it. And so that's definitely, I can see a value, I can see a need for research, for technology, allowing this kind of implementation being done a lot easier. And then this kind of stuff would go away.
Yeah, Mark agree also, and that the same goes for RPKI that you mentioned. You do it for others. That's the point.
No, that's
I just want to ask you.
The RPKI thing is different because I do it for myself. I protect my IP prefixes for being hijacked, right? Or at least origin validation can be done with that. So a third party can check.
I mean, you do it for others. Yeah, that's you do for self for others. That's in the same way. You ensure that you're not obviously the source of the DDoS, like the RPKI, you ensure yourself, yeah.
Yeah, but with RPKI, I make sure that the prefixes I distribute are the ones I have, you know, and that the origin is with me. So I protect my prefixes, and with DDoS, I protect my my network from being abused for DDoS that is hitting somebody else.
I want to ask you, Thomas, maybe just a quick things about, because we are into trying to research operational and experimenting, and DKIX has also kind of long story doing research with academics. We mentioned SIGCOMM, we mentioned different things. You have a strong team of research and development participating in different projects. And so can you tell a little bit more about what the benefits and what was in operation as a result?
Sure. So, you know, in general, we see that the internet is not a static thing, which we, you know, which just deploy and then run forever. We see that there's a lot of development going on also in the internet infrastructure over time, and we need to make sure that we somehow also drive this development, right? So that we come up with suggestions or also standardization that makes sure that the things we think is valuable for our customers can be used by them. And so we have been part of many research projects for years, you know, investigating, for instance, software-defined networking for internet exchanges, because SDN back then, 5 years ago, was mainly used within a network. You know, Google was heavily using it, Facebook was heavily using it, and developed it and pushed it very hard for their purpose. And the question which came up is, how can we as internet exchanges use SDN technology to connect networks, SDN-enabled networks? What will be the benefit, and how can this happen? And you know, because then you come to a view of an application-driven network, right? You know, which can be configured and which is programmable and all this kind of stuff. And there are different functions within the network, and how can they be orchestrated? And so we spent a lot of things there, and one outcome was that you know, we need to develop DKIX in a direction that it is providing an API so that it can be used by applications for you know, providing different interconnection services, like, you know, peering is one, but cloud on-ramping in another one, or point-to-point connections between data centers.
You mentioned IX API, right?
Exactly. So that is you know, from a thought process, something that is that developed into IX API, right?
With AMS-IX and Links part of it as well.
And you know, we did that together with AMS-IX and Links, NetNod. And also Interaction and Epsilon Tel, they have been you know, big supporters in standardizing this, and we made it open and public to for everybody. And so we have seen quite some usage of this, or quite some networks implemented it as consumers, as clients, but also already some other bodies are implementing it as providers, so that their network is now programmable. And this is exactly one example. Also coming back to DDoS attacks, F7999 was standardized, you know, together with DKIX. DKIX, I think, is one of the authors of this. And so, yeah, so we spend a lot of time and energy in looking into how we can develop the internet infrastructure further by research and by standardization.
Naria?
I want to ask Thomas, how do you secure that? How do you go about securing an SDN-based IX infrastructure? I mean, really. I mean, in the past we've had, if you look back at the old telco style of doing things, where you had these, you know, dirty great big switches that were built over a period of years by teams of engineers and not very much code. It was all locked down, it worked in certain ways, and there was a lot of reliability around that. So how do we do that now? If every element of it is programmable, if anybody across the whole connectivity fabric can breach that and do whatever they like, how do we reduce the risk of DDoSes? I mean, we talk about BCP 38, we're talking about BCP goodness knows what.
So actually, it is not, you know, from my point of view, you can't run a network where you have fine-grained control for all the different participants, especially if you talk about thousands of participants and terabits of traffic, right? Because that's what our scale is today, right? We talk about 10 terabits per second of peak traffic and more than 1,000 networks on one IXP. And and so we don't give fine-grained control on our routers or on our switches, which are distributed over 37 data centers, for instance, in Frankfurt. So it's a distributed internet exchange. It's not only one switch, right?
So what you're doing is you're isolating the access to those different programmable points.
Exactly. So we have clearly defined.
This is the way we've got to secure it. Yeah.
Yeah, exactly. So we have clearly defined, resources which you can access, and only this part of only this clearly defined resources, like let's say a point-to-point connection, an e-pipe in the end, right? You can order one or request one, and then you get this resource with a clear definition of what is the capacity, how does the path look like, and all this kind of stuff, and then based on that you have security on this level.
Maybe Brad and Kevin, you want to maybe just talk about that a little bit more, and then maybe we can move to the second topic. We'll get 20 minutes left.
Sorry, who was that you asked?
I mean, if you want to talk a little bit about what between academics and research kind of work's been done in different regions, or had more comments, and maybe we can move to a little bit more on the second topic with public option for the core, and just open up that discussion.
Well, I would just add that, I mean, I think academia in particular, research and education networks are absolutely the place to be experimenting with this type of thing. I think that is a role they can very clearly play. I'm not going to say they don't have commercial pressures, because they absolutely do, and they have to keep their networks up and running. But they do have some facilities and the interest to work on these sort of future internet initiatives. And they have wide-scale test beds, more importantly, as well. So
like Géant with Rare, with a free router based on P4.
Exactly. So, and just to point out, I mean, there is this test bed in Switzerland, right, between ETHZ and Switch on the Sion or Sion, I don't know how to pronounce this, which actually seems to be quite a sort of active semi-production network. And actually, I think it's actually being used by a number of commercial entities, if I'm not mistaken. So yeah, I mean, I think it's for sure. We should be looking at this. Somebody should be looking at this. I don't want to dismiss this in any way. It's just, I think, there's 70,000 networks that would have to adopt this.
Okay.
It's kind of how I'm feeling right now. That's kind of my entire takeaway, is that the importance there, I'm not knocking the importance or at all. It is something that we definitely have to be looking forward in our thinking and design. But I just want to bring up, are we asking the right questions? What are we actually trying to solve for? Who is coming up with this? Until we can actually answer where we need to go, we can come up with different ideas and test beds and try them all out. But we need to come up with as a community, it needs to be decided what we're looking to do. I think it ultimately comes down to the research networks can be doing this and doing these projects, but ultimately I think it needs to come down to the community that has to provide feedback, to give us the guidelines of what they're looking for, so that we're not going to build something that's not going to be needed or useful.
Then I want to open to one of the things that we have seen in the backbone of internet. Most of the big players, CDNs, are actually going to privatize their own backbone. They have their own fibers globally. They have their own sea cables. And the transit providers kind of move in a different way. Just the IXP community get a different position as well, due to the presence of CDNs who go closer to the users. And the paper that I mentioned at the beginning with the public option for the core just come up from a way of getting a non-profit kind of large internet exchange globally or per regions is not really properly defined, where they have, it's called the POC, with a non-profit organization, transparent and so, where we have the last mile providers who connect to the users and to the CSP, the content service providers as well. And they introduce in the paper then is economics need to be there, and they talk about the VCJ with auction mechanism, who is used many different locations, even in US for VK Clark and Groves. Like, could economics part of the proposal? This is for infrastructures. Then when we see moving that such privatized backbones and solutions, then you all have been able to read before, maybe you have some few comments just on the type of architecture that is proposed. I just present shortly. Thomas? Brad, maybe you want to start because you're onto, yeah, many different views had on the previous discussion.
Yeah, so it's hard for those attending who have not read the paper, but I'm going to try to do my best to describe how the architecture is in this paper. You have your bottom layer of the design of being your customers, and they're reaching up to a last mile provider. Currently, how the internet is now, you have your last mile provider. From there, though, the direction that this paper is proposing is that instead of going from the last mile provider through normal networking, they create a public offered core that you would connect to. And you would connect to this core and you'd pay for the bits used. And it would basically like a subsidized version of a core. What is being done now with the large players who are privatizing the cores, to me, it makes sense. That's the next evolution. After going through this paper pretty deeply, I have issues with the economic aspects of the proposals, but ultimately it comes down to it brings up more questions. I feel that it requires a deeper discussion. For example, how do you determine what the value is of connecting to a public core, and how do you choose a rate to charge someone? Do you go to a bit transferred? Do you get charged a flat fee? So who's controlling that? If it's all set as a nonprofit, that's great for the nonprofit of that country. But what happens when you have to cross international borders? Who controls the pricing at that point? It just brings up a lot of other questions. And I'll let the other panelists chime in here.
Nara?
So I was thinking this through, and so who might be the entities that could be motivated to put together such a sort of all encompassing or all highly, available across the whole globe type infrastructure? And it struck me that the sort of entities that exist today that might be motivated to do that are ones that, I don't know, have not really got a great reputation in the internet space. And those ones I'm thinking of would be the International Telecommunications Union. They might say, hey, here is a development program, or you poorer countries that can't afford to spend some money to get better international connectivity, and you all want your people to be able to watch Netflix and other content things just like everybody else can. We'll give you this. I'm not convinced that would be done in as well a manner as we have done today. And who might else be? Well, I'm sort of thinking, coming from a country that is aligned with some other countries along the lines of what we call the Five Eyes, perhaps you might see the Five Eyes countries getting together to form some sort of international backbone like this in order to funnel everybody's traffic into a nice big pipe that they can easily access. And then there would be corresponding, dare I say, alliances that might have similar sorts of security intention, that might not be constructive ultimately for the population that need to connect across these networks. Or maybe they will be. Maybe I'm just not sympathetic enough. So if it was perhaps a completely non-profit, virtuous entity, perhaps maybe that's where the IXs could come in. Maybe we IXs need to get together and pool our resources to interconnect to each other and make it cheaper for our members and our supporters to interconnect along the lines of, you know, this is the not-for-profit model that we operate on today on our IX Australia. Maybe that's the way it could work. I don't know, there's just some thoughts from me.
Yeah.
Yeah, I mean, I would probably share some of those concerns, and that was my thought as well. You know, who controls all of this and for what purpose? But you know, what I would say is, you know, there used to be this thing called, you know, a telecoms network for public good, and it was called monopoly telcos, which they, you know, countries, national governments built telecommunications networks, you know, at public expense and ostensibly for the public good. And, you know, to be fair, for 100 years, they probably did, you know, roll out communications to places which probably would never have got communications. And, you know, that was a positive thing. But, you know, time moved on and they became sort of a bit complacent, a bit inefficient, didn't really pick up on the internet very quickly. So, you know, whatever the next future internet might be, this may happen. You know, and then, you know, you end up with sort of quite high costs and poor service. And, you know, would this essentially be replicated, this issue? Now, I'm a bit skeptical about this for the sort of whole of the world, I must say, or for very large scale. But I can see that this could be useful for bandwidth poor and expensive bandwidth areas, regions. So there are some sort of landlocked countries in the middle of Asia, and there's landlocked countries in the middle of Africa, you know, where this actually may be beneficial because they have very limited ways of getting the internet in, or at least, you know, sort of fiber, for example. I mean, satellite's obviously an option. And I could see that, you know, because of their sort of political difficulties and geographical difficulties getting cheap and efficient bandwidth, I could see that this could have some benefit there, and there might be some willingness to do this. I mean, in fact, I know there's some willingness to do this, but as ever, it's always politics. It's you're crossing, when you start crossing borders and you start having regulatory regimes and you start having vested interests, and also, let's say, states that don't really want people to have easy access to the internet. I think this is where it all starts to break down. So I think the idea is very good. I think it does have applicability in a number of regions, actually. And by the way, not just in developing regions. I would say even in sort of, you know, Arctic regions like Canada, this could be the case too. But yeah, I think it was, you know, case by case basis, and just, you know, let's be just alert or aware to the fact that, you know, we used to have this.
And then NBN was the, as Kevin mentioned, a public, and so was something was happening in Australia. Then maybe you have a point of view on the way this is running, and in UK is similar things as well. Was non-profit but public, or could be risk of being sold to privatized company at the end. Or can you tell us more, Nariel?
That might be my cue. So both of our major parties of government have their policy platform to sell the infrastructure, which is the national broadband network, at some point in the future. I think there is an actual date they have in mind, but I forget what it is now. So the concept behind the national broadband network was really to build an infrastructure that would connect every single household and business right across Australia. So a very large country with some very remote locations. In its early days, it was argued by the opposing side of government that it would be a white elephant, that no one would ever need it. This business, who needs more than 6 megabits per second to the home? I mean, that's just ridiculous. It's ridiculous, way too much. Yeah, I know. Here we are in COVID land where we all want at least 15 meg, don't we? So we can have 3 Zoom conferences and some streaming video all at the same time for the entertainment. But yes, that infrastructure was originally envisaged as being a fibre optic cable infrastructure to every single premises. Politics intervened, and we had a change of government in order to convince those that called it a white elephant that it should be scrapped and abolished. The concept was, well, let's just integrate some of the other technologies. So integrate HFC and fibre to the node into this system so that you could then make it cheaper and get it out faster. And of course, then they realised they had to rejig their entire system. So instead of getting it out faster, they took another 2 years to negotiate a deal with the incumbent and to rebuild their IT systems to add equipment that was going to be obsolete within 5 years. Yes, but largely we have got this infrastructure that has changed the competitive landscape and will continue to change the competitive landscape, because we won't just have a small number of players with that physical infrastructure able to use physical infrastructure to get to the last mile, to get to the consumers, to get to the businesses. Now, with the national platform in place, any ISP should be able to deliver services over the top of that. And maybe in the future, we may end up with a whole range of different types of services across multiple different VLANs into our homes and businesses. At this point in time, it's just the one provider across a single infrastructure. It has, you'd have to say that it has had a fraught build history. It is, you'd have to say mostly successful, given that we have had a lot of times locked in our houses for the last 6 months, and the NBN has largely worked. But there are still, as I said earlier in this, there are still certainly large numbers of people that are not connected. And there are still children in families that can't get access to schools because they don't have internet. And this is a well-developed country. And I know we're not alone here, even in other developed countries.
Yeah. Thomas, you may want to have.
So yeah, we in Germany, we have Deutsche Telekom, and I can remember when Deutsche Telekom was owned by the government and was running the telecom infrastructure in Germany. And I was a kid back then, but I can remember having huge discussions with my parents about the bill which I generated dialing into the internet. And so I'm not a big supporter of government or publicly owned infrastructure because of this experience. I can see that sometimes when there is not a clear business case for businesses because the risk is too high or cannot be assessed properly, then it makes sense that the public jumps in and builds something. But usually it shouldn't run the infrastructure because the public, from my experience, is quite bad in running infrastructure over a long time because usually then it gets expensive, slow, and things like that. So, the approach we have in Germany, for instance, in connecting homes, and as Narelle was just saying, we also in Germany have still places which are not, which do not have internet at all, or at least not, broadband internet. And so the public is jumping in, the government is jumping in, giving money to internet service providers, building infrastructure there, but they need to run it then for, I think, 20 years or something, and they need to open it up to competitors. So if the government is paying for it to make the business case work, then it is open access infrastructure. And in models like this, I can see that it makes sense to have the public involved in building internet infrastructure. But we need to be very, very careful with having the public on this, and look how well we did with building the internet infrastructure so far. It is from my point of view, it worked pretty well, and I'm pretty certain if we have more involvement from the public, I'm not sure if that would be for the better. So we need to definitely look into the case where it's helpful.
And as an internet exchange community, we're different player. We come from the interest of internet. We may do business or non-profit, and most of internet exchange are small and are actually non-profit as well, just even voluntary based for most of them.
and look how well that worked, right? So most
Yeah.
of the internet exchanges all over the world are community internet exchanges, which are run by a few people or also bigger organizations. But you know, they often do that for non-for-profit, and this is doing very, very well. And of course, we have also some internet exchanges which are run for profit, right? You know, from my point of view, it really depends on which case you're looking at and how this, you know, which model can be applied and works well.
I kind of envision in long term that community need to maintain that non-profit, not government based, could be helped by the public and government and so, but yeah, has operating and come up with different solution. The first part of the panel where we mentioned about experimenting and so that's something we need to, you know, just focus, as Brad, you mentioned, maybe on a very specific problem that for internet exchange, but a larger way with existing flexible programmable data plane and so way of fixing as a community based for a largely non-profit. That may be one of the solutions, or just different organization and workshop. Will take some time, but that's what I think that we are as a community can provide as kind of solution without expecting most of the different big players or even governments in some way, and then the diversity of who community. And maybe Narelle, just one question. When the NBN and the Internet Exchange Network you have in Australia, how that kind of relation?
We're actually quite separate to the NBN. The only reason why I talk to the NBN is actually to go and represent the views of my members. And my members are all the RSPs and content providers across Australia. So we sit in, our exchange equipment all sits in the data centres. The NBN has its own points of presence right across the country, connecting those last mile locations. Maybe I should be connecting the IXs right across all of that. Maybe, I don't, you know, if my members tell me to, then we will.
Then I think we're getting to the time now. It's already past an hour. It was quite quick. And then I want to thank you everyone. Just a quick conclusion as I hope that we're gonna get other opportunity out of that panel discussion of the different region and be in contact with academics as well and other projects, continue to do so. That initiatives of being able to get different people all together maybe need to be on the running all the time. Then thank you everyone.
Thank you. Great, thank you.
Thanks for joining.
Have
a nice day. Bye-bye.
Thank you.